Welcome to Unit 2, Lesson 8, in Behavior Part 1. Let's investigate the shape of polynomials. Okay, so let's look here. Here's the big idea that's 11. For even functions, so we're talking even, 2, 4, 6, 8, 10, 12, 14, 16. The basic shape is going to be a U, and we're only worried about the ends, okay? So for this lesson, we're only worried about positive functions and we're only worried about the ends. Now, for odd functions, not 1 because x to the 1 is linear, but x cubed, x to the 5th, to the 7th, to the 9th, 11th, 13th, 15th. The ends wind up in different places. So x even, x to an even degree, and remember, degree equals highest exponent. No matter how many terms in a polynomial, we're only worried about the highest exponent. If it's even, it ends in the same spot. If it's odd, it ends in a different spot. Now, so in this lesson, we're only worried about these. And let's look at the notation. As x goes to negative infinity, as x goes this way, y goes this way. So that's for this one. Now, as x goes positive, let's do this in a different color. As x goes positive, y goes positive. So for even functions, they end in the same spot. Now, if we're looking at odd functions, x going negative, y goes negative, or f of x goes negative. And for x going positive, y goes positive. So they end in different spot. And this little line, the arrow means goes to. And we all know that a sideways 8 means infinity, negative infinity or positive infinity. And I'll worry about this one in lesson 9. So don't worry about the bottom two graphs just yet. Okay, 8.1. Here is our notice and view. What do you notice? What do you wonder? So what I wanted you guys to notice about this is, first things first, let's look at the degree. The highest exponent is the degree. So for the first one, we have positive x even, which means it goes to different ends. But what I want you to really pay attention to here is the window. Now, on a regular calculator, when you reset it, the ends of the graph should be 10 and negative 10 on x and 10 and negative 10 on y. But somebody stretched the windows out because we're not worried about the middle of the graph. Ignore all of this. We're only worried about the very ends of the graph. Why? Because the degree tells us about the end of the graph, and that's what we're studying. And the same thing for the x even. They end in the same spot. We're not worried about the middle of the graph in this lesson. It's not important. We're only worried about the ends. Okay, so let's look at activity 8.2, because I already filled in the column for you. So in the column, you're supposed to put the functions into the calculator, y1, y2, y3, and y4. And then after you put all four calculators, so you hit the y equals, and we know how to put the things in. So you have x, t, theta, n, which is next to the green button to find x. And then if you're above 2, you hit caret. If it's x squared, you can hit the x squared button, which is to the left of the 7. If your exponent is above 2, you can hit the caret button and type whatever. But remember, after you hit the caret, you have to hit the right arrow. And the buttons look like this with a triangle on it. So you have to hit the right arrow to bring the cursor back down and hit the +1. So we do that, and then we hit second graph to see the table of values. And you scroll up or down for -1, -10, +1, and +10. Now, if you want to get faster to 100 and -100, you hit second, you hit window, and you hit delta. You look at the table setup, you change the table setup to whatever number you want it to be. 1,000, negative 1,000, and then you hit second graph again to look at the tables, and that'll get you quickly to any value you want to see. So now, if we look at the parabolas, you got two x evens here. You got x squared and x to the fourth. And if you look at it, look how quickly the numbers grow. So a higher exponent will make the numbers grow exponentially larger. Some of you are seeing on your calculators like 1e12. What that means is 1 times 10 to the 12th power. So there are 11 zeros in the number 1. That's what that means. So 1e12 is 1 times 10 to the 12th, which is 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and a 1 for those functions. Now you might see negative 1e8 and negative 1e15 for at negative 1,000 in that first row, but I put the actual numbers in there. I actually scrolled through and looked at the numbers that was in the calculator, and this was supposed to be in the calculator. So as we can see, as x starts to get very large, our y values get very large and very small, very large and very small. So these numbers are astronomical, so that's why we're only worried about the end behavior. So that was the whole point of this exercise. And now looking at our final exercise here. So what I'm going to do with this is I'm going to put each term separately into the calculator into y. So we'll get y1, y2, y3, y4, y5, and y6, so that we can compare each term. And then I'll put these in different colors. So we'll start y1 with purple. We'll do y2 in red. Do y3 in blue. Y4 in green. Y5 in orange. And 60, because it's a constant, is always going to stay 60. So I'll just write that in purple as well. So the degree of the polynomial. We know that the degree of a polynomial is its highest exponent. So this is 5th degree. And so now I'll put that in. And the end behavior of the polynomial. Draw it as x goes to positive infinity. F of x goes to, or y, it doesn't matter, goes to positive infinity as x goes to negative infinity, y goes to negative infinity. That's the end behavior of the polynomial. The first thing you want to do with a polynomial is graph it and then figure out the notation. So you can see as x gets larger, y gets larger. As x gets smaller, y gets smaller. And you have to familiarize yourself with the language. So I'm going to put each term in the y, and then I'll write the numbers down so that you can see what they do. Okay, so we put the numbers in. Remember, 2x to the 5th is purple, 5x to the 4th is red, 30x cubed is blue, 5x squared is green, and 88x is orange. And so as you go down the list, as x gets further away, we can see that x to the 5th, it gets larger than any of the other numbers. Yeah, you have some variation in lesser numbers, but we're thinking as x gets far away from 0, and at 5, the x to the 5th term is already outdistanced itself by almost 2 compared to 30x cubed. So this is the point. As x gets further and further away, y climbs very quickly.